Today, on how it's made. Clay liquor jugs. Poultry deli meats. And NASCAR engines. The clay liquor jug is a product with an illicit past. In 19th century America, this distinctive stoneware jug was used to contain backwoods brew, moonshine whiskey, that was produced under the cover of night to avoid scrutiny from American authorities so it could be sold tax-free. Today, they still uncork the little brown jug to serve up old-time corn whiskey. Replicas like this one add an authentic touch to the traditional brew. The jugs start with raw clay, dug out of the ground and crushed into little particles. They also break up defective and damaged pottery and recycle it into the process so nothing is wasted. Next, a shaft with protruding knives mixes the clay with water and fortifying chemicals. When the clay reaches a doughy consistency, a vacuum sucks out the air pockets. And then machinery forces it through a die to form a long log. In log form, the clay is easier to handle. The potter pulls off some chunks of clay and shapes them into patties. He presses the patties into molds of the top and bottom parts of the clay liquor jug. He inserts each mold in a holding ring and spins it. A wooden tool now sculpts the jug's top section from the inside. Clay migrates up the walls of the mold and takes its shape. The potter pokes a wooden dowel in the neck of the jug to round it out. As tools shape the lower body of the liquor jug, the potter sprays water on the rim. This makes the rim sticky, which will allow the bottom portion of the jug to adhere to the top. Still in the molds, he presses the two parts of the jug together and the moistened clay bonds. Once the clay has dried, the next craftsperson pries it from the molds and it comes out in one piece. She removes any unwanted bits and transfers the jug to the workbench. She levels the lip of the jug with a stick and spins the jug on a pottery wheel to scrape off surplus clay at the seam. She smooths down rough spots on the exterior surface with a wet sponge. At this point, the clay is still fairly supple and responds to moisture. Meanwhile, jug handles are taking shape in this tub. Steel paddles force the clay through holes in the bottom, producing ribbons of clay that will now be shaped into curved handles. The potter moistens one end of the clay ribbon and presses it to the neck of the jug. She must apply just the right amount of pressure or it will fall off. She pulls the clay ribbon into a distinctive curve and presses the other end to the side of the jug. The curvature must be similar from jug to jug, and producing a consistent shape every time takes practice. At the glazing station, an operator tests a pump which spurts glaze upwards, creating a brief fountain of glaze. With a paddle, he swishes the solution around to keep the glaze particles suspended. Then he immerses the top of the jug in the liquid to give the clay liquor jug that familiar two-toned look. He pumps glaze inside the jug, giving it a leak-proof lining that will allow it to hold liquids. The next worker stamps product information on the side of the jug using ceramic inks. Next, they prepare a different glaze. The worker dips the bottom portion of the jug in it, and it appears to completely obscure the carefully applied product information. But when the glaze dries, it will become transparent, and the stamp will be visible again. The next worker scuffs off the glaze on the base to keep the jug from sticking to the shelves in the kiln. They fire the whiskey jugs at over 1200 degrees Celsius for 8 hours. This hardens the clay and deepens the glaze. It's taken a total of 19 steps and 1 week to transform a couple of lumps of clay into a little brown jug. And it's sure to add a touch of nostalgia to cocktail hour. Man cannot live by bread alone, but add a few slices of chicken or turkey deli meat and you've got a meal. Poultry deli meat is a popular alternative to corned beef or salami, and that's because it's less fatty, any way you slice it. When it comes to making poultry deli meats, it's all in the seasoning. From fiery southwestern turkey to hot sauce marinated chicken, they really know how to spice it up. They begin with plenty of filtered water. It will be used to disperse the specially formulated seasonings. There's a different blend for every product, and they include salt and different herbs and spices. They add honey because this is a honey maple recipe, and while that's all being mixed, they check the temperature of the raw poultry to confirm it's in the safe range. If it's even slightly off, there's a risk of bacterial growth, so the whole batch would have to be rejected. But this poultry has been well chilled. The stitch pump machine's long steel needles repeatedly inject seasoning solution into the breast meat. Excess liquid drains through the conveyor as the chicken is transferred to a holding area to marinate for at least 2 hours. Next, numerous lumpy rollers massage the chicken and break down fiber to tenderize the meat. Then, in a tumbler, metal paddles vigorously knead the meat. This tenderizes it even more and releases a natural protein that will eventually bind several breasts into one big piece. Meanwhile, in the turkey kitchen, workers shape and season previously marinated meat and apply strips of bacon to the top. The employee arranges them in a crisscross pattern for full coverage. He dusts it with a mix of seasonings and then wraps it in thick plastic. Once enclosed in the plastic, he can press the turkey breast into a more perfect shape. For a different flavor, they drench some turkey breasts in a spicy southwestern marinade. After folding the turkey meat to the desired shape, the worker adds salsa and seasonings to complete the recipe. A little more hand shaping, and it's ready for the oven. Back on the chicken line, it's the same idea, but with a different twist. Chicken breasts are too small to shape by hand, so they funnel them into thermoformed plastic molds. As the molds move forward, a worker sprinkles spices onto the meat, while another swabs juices to test for pathogens, as part of a quality control program. Equipment heat seals the plastic molds and then cuts them free from the matrix. Then they're on their way to the smoke oven. They spend 6 hours smoking at 74 degrees Celsius. The protein released earlier by kneading causes the chicken parts to adhere and take the shape of the mold. Once they've been temperature checked, it's on to the next station. Here, workers peel off the cooking mold and drain the excess juices. Then the molded breasts go through a fryer. The hot canola oil browns the outside of the chicken meat for a more appealing and tasty effect. Meanwhile, workers swish other cooked chicken breasts in hot buffalo wing sauce to really kick up the spice a few notches. And after extra seasoning, the chicken travels through a long arc of electric heat rods. This is a special convection oven. Fans blow the heat from the rods onto the meat to complete the cooking process. By now, the turkey deli meat has also been thoroughly cooked and crisped. They transfer the turkey-filled bags to clam-like devices which close around them. Inside, a vacuum sucks out the air to shrink the packaging around the turkey and keep it fresh. It's taken about 8 hours to produce this poultry deli meat. Refrigerated, it should last about 35 days. Unless there's a hungry crowd. NASCAR, an acronym for the National Association for Stock Car Auto Racing, is one of the most popular spectator sports in North America. NASCAR vehicles are modeled after certain American-made four-door passenger cars, but with far more powerful engines. No overhead camshaft engines on this track. For tradition's sake, NASCAR rules require an overhead valve engine, an older type of configuration, also known as a pushrod engine. Designing the engine takes about a year and a half. It culminates in a detailed computer model, an anatomical rendering of the engine in full detail, right down to every last nut and bolt. The computer model guides a stereolithography machine to produce a plastic prototype of each engine component. The machine repeatedly outputs paper-thin layers of photosensitive liquid resin, which an ultraviolet laser instantly solidifies. Over the course of several hours of resin layering, the prototype component takes shape. Technicians test it in conjunction with other prototype components and make any necessary adjustments to the design. Then, computer-controlled machining equipment produces a metal prototype. When every component has gone through this process, the engine design gets the go-ahead to move into production. The factory first casts the basic shape of certain components in a mold, then machines that shape to its final form. Here, computer-guided hones finish the engine's 8-cylinder bores, the chambers in which the power-generating combustion cycles will occur. Technicians take very precise measurements to ensure the bore's diameter and roundness meet specifications. Then they flip the engine block upside down, oil the crankshaft bearings, position the crankshaft on those bearings, and lock it in with bolted-on caps. As the pistons inside the cylinders move up and down, they rotate the crankshaft, driving the clutch and transmission which propel the race car. With this little black component called a wrist pin, they join the piston to a connecting rod. Next, they fit 2 rings on the piston. The top one seals the cylinder, maximizing the pressure inside, which optimizes combustion. The bottom ring skims excess oil off the cylinder walls between combustion cycles, which prevents the car from burning oil. After inserting a piston all the way down into the cylinder bore, they grease the upper portion to prepare for measuring the compression ratio, which must comply with NASCAR rules. The compression ratio refers to the volume of space in which the piston compresses the gas and fuel mixture entering the cylinder. To take this critical measurement, they raise the piston all the way to the top dead center point, then verify the positioning with gauges. They seal the top of the cylinder with a see-through plastic plate. Then, with a syringe, inject alcohol into the space in between. The markings on the syringe tell them how many cc's, or cubic centimeters, filling that space requires. This volume measurement indicates the compression ratio. The higher the compression ratio, the more horsepower the engine produces. They repeat this test with each cylinder. They flip the engine block upside down and put each piston's connecting rod in the corresponding position on the crankshaft. Then lock the piston in place with bolted-on connection caps. Now the technician closes up the bottom of the engine. Meanwhile, a device called a profilometer inspects the camshaft. The camshaft moves the intake and exhaust valves at the top of each cylinder, allowing the fuel and air mixture in and the combustion gases out. This testing ensures the camshaft is straight and that its surface is slightly rough, so that lubricating oil will cling to it. The engine build is now about halfway there. In a pushrod engine, the camshaft is located, as we've just seen, above the crankshaft. It opens and closes the valves with a system of lifters, rods, and rocker arms. In the more modern overhead camshaft configuration, the camshaft sits on top of the cylinders, moving the valves directly. Building the NASCAR engine continues with the installation of this aluminum motor plate, by which mechanics will mount the engine in the car. Next, the timing belt, which links the camshaft to the crankshaft, ensuring they turn in sync and maintain the correct timing. At the core of the belt is a woven material that's 5 times stronger than steel. Other technicians use a gauge to measure how much force it takes to compress the valve springs. This quality control check ensures that spring tension is within a specific range. Each cylinder has an intake valve and an exhaust valve. Technicians use a compression tool to squeeze a spring over each one. Then they secure the spring with a locking clip. The valves are located in the top section of the engine, called the cylinder head, which technicians now bolt onto the engine block. Next, they assemble the pushrod system, by which the camshaft opens and closes the valves. First, rocker stands, then pushrods. These insert into lifters, which connect to the camshaft. And finally, rocker arms. One end of each arm goes on the pushrod, the other sits on the valve. When the camshaft turns, the system opens and closes the valves. Technicians close up the cylinder head with a valve cover. Next, they install the engine cooling system, starting with the water manifold. After mounting a cover to protect the cam belt from rocks and other debris, they install the water pump. It circulates cold water through the engine to prevent overheating. Having absorbed the heat, the water exits the engine via the manifold, then travels to the radiator, which cools it back down. Then the pump, driven by this pulley, sends the water back into the engine to repeat the cycle. Next, technicians mount the alternator. It generates electricity to run the engine and other components, such as the air conditioning, the dashboard gauges, and fans which cool the brakes, tires, and rear end. This belt drives both the alternator and the water pump pulley. Next, technicians install the oil pump. It sucks hot oil out of the engine, sends it to the oil radiator for cooling, then pumps it back into the engine. Now the distributor. It sends electricity from the alternator-charged car battery to the spark plugs. The spark plugs fire, igniting the fuel and air mixture in each cylinder, producing a mini explosion that drives the piston. This component, the intake manifold, feeds the air and fuel mixture to the cylinder intake valves. The carburetor regulates the mixture ratio by metering the right amount of fuel to the amount of air coming in. Technicians install the numerous parts that make up the clutch. Next, the starter ring, which engages with the starter to fire up the engine. Finally, they mount the bell housing, a cover that protects the clutch from debris and connects the engine to the transmission. The factory hooks up every engine it produces to a testing machine. The machine starts up and runs the motor, analyzing some 300 performance criteria, from revolutions per minute to fuel flow. At the same time, 3 remote-controlled cameras shooting from different angles enable technicians to zoom in and view on a monitor anything they need to visually inspect. All this to ensure the engine they've built will have a winning track record.